Let's step into a world where mathematics behaves like a wise judge, quietly comparing different averages and deciding who stands taller. Today's question says, in an AI performance evaluation study, two performance metrics of a machine learning model are recorded. Let the two observed values be x1 and x2. We have to find the arithmetic mean, geometric mean, and harmonic mean, and then show that arithmetic mean is greater than or equal to geometric mean, which is greater than or equal to harmonic mean. Now imagine these two values as two performance scores of a model. We want to summarize them in three different ways, and then understand a beautiful relationship between these summaries. Let us begin. First, the arithmetic mean. The formula is arithmetic mean equals x1 plus x2 divided by 2. This is the simplest average. It treats both values equally and gives a balanced center. Now the geometric mean. The formula is geometric mean equals square root of x1 multiplied by x2. This mean is useful when values are related multiplicatively, like growth or ratios. Now the harmonic mean. The formula is harmonic mean equals n divided by sum of reciprocals. Since there are two observations, n equals 2. So harmonic mean equals 2 divided by open bracket 1 divided by x1 plus 1 divided by x2 close bracket. Now simplify this. Harmonic mean equals 2 divided by open bracket x2 plus x1 divided by x1 multiplied by x2 close bracket. So harmonic mean equals 2 multiplied by x1 multiplied by x2 divided by x1 plus x2. Now we have all three means. Arithmetic mean equals x1 plus x2 divided by 2. Geometric mean equals square root of x1 multiplied by x2. Harmonic mean equals 2 multiplied by x1 multiplied by x2 divided by x1 plus x2. Now comes the beautiful part, the proof. First, we prove that arithmetic mean is greater than or equal to geometric mean. We start with a basic idea. The square of any real number is always greater than or equal to 0. So we take open bracket x1 minus x2 close bracket whole square greater than or equal to 0. Now expand this. x1 square plus x2 square minus 2 multiplied by x1 multiplied by x2 is greater than or equal to 0. Now add 4 multiplied by x1 multiplied by x2 on both sides. So we get x1 square plus x2 square plus 2 multiplied by x1 multiplied by x2 is greater than or equal to 4 multiplied by x1 multiplied by x2. The left side becomes open bracket x1 plus x2 close bracket whole square. So open bracket x1 plus x2 close bracket whole square is greater than or equal to 4 multiplied by x1 multiplied by x2. Now take square root on both sides. x1 plus x2 is greater than or equal to 2 multiplied by square root of x1 multiplied by x2. Now divide both sides by 2. x1 plus x2 divided by 2 is greater than or equal to square root of x1 multiplied by x2. That means arithmetic mean is greater than or equal to geometric mean. Now let us show that geometric mean is greater than or equal to harmonic mean. We already have geometric mean equals square root of x1 multiplied by x2. Harmonic mean equals 2 multiplied by x1 multiplied by x2 divided by x1 plus x2. Now we compare them. We want to show that square root of x1 multiplied by x2 is greater than or equal to 2 multiplied by x1 multiplied by x2 divided by x1 plus x2. Divide both sides by square root of x1 multiplied by x2. So we get 1 is greater than or equal to 2 multiplied by square root of x1 multiplied by x2 divided by x1 plus x2. Now rearrange this. x1 plus x2 is greater than or equal to 2 multiplied by square root of x1 multiplied by x2. But this is exactly what we already proved earlier, so this is true. Hence, geometric mean is greater than or equal to harmonic mean. So finally, we conclude, arithmetic mean is greater than or equal to geometric mean, and geometric mean is greater than or equal to harmonic mean. In short, arithmetic mean is greater than or equal to geometric mean is greater than or equal to harmonic mean. This is a very powerful and elegant result in mathematics. It tells us that for any two positive values, these three averages always follow this order. And this relationship appears everywhere, from data science to physics to economics. So remember this as a golden rule of averages.